So if you remember what I talked about in the class about the integration and differentiations, and then now in JC2 or in the AS level ideas or topic, so then we have covered a lot of functions now. So if back then it's just only like x squared and chain rule, product rule with that, so now we have to acknowledge or learn more functions. For example, like ln x. So ln x, how to derive this is actually more complicated than just x, because like a lot of things actually involved. But then if you want to know, let me show you later. And then this is ex, exponential, and then there is also like sine x. I think I mentioned that already. Cos x and tangent x. Probably deriving the trigonometric function could be more familiar to you. The ln x and ex is they're kind of like a different, because there's a certain rule that we have not learned, but actually they exist in math. So by the rule, if you're interested, then you can just see the proof. The dy dx, or the differentiation for each of this, it will be 1 over x. It stays ex. It goes cos x. This is negative sine x, and this is secant squared x. So we just like memorize or remember this because that becomes the rule. But then if you really want to know why is it like that, then you have to go deeper. Okay, so then, but this is the idea. So then differentiating this, so then it means that we also know that if we put it backward, we reverse the process, or we call it reverse. We reverse the differentiation. This is what we call as integration, right? That's what we call as integration. So then that's why like there is a integration of 1 over x dx. That's ln x, but then we put the plus c because it could the c, the constant or that random number, if you derive it, it could be just 0. So it goes like kind of like that. So and that works for, again, the chain rule, product rule, with all what you have learned in JC1, they could be applied here. So just for a simple example here, let me give it to you. For example, the y is 3 ln x squared plus 3x. So the dy dx will be, says 3, and then what is the derivative of ln? So it will be 1 over, right? So it's 1 over x squared plus 3x. But then remember the chain rule, like the peeling. So we've done with the ln, but then there is the inside part, which is the x squared plus 3x. So then I don't have the space, so times 2x plus 3. Then now it depends whether we need to simplify or not, but it's kind of like the idea. So after this, I'll just give you more examples, just practically how you differentiate, so then you know how to integrate. So because they're basically connected, it's so hard that we do integration actually if we are not very good in differentiation. So that's why I also mentioned in the class, like, how do you know that your integration is correct? You have to go with the differentiation. So it's kind of like that.